Hello, students of Niagara Region. My name is Rachel. I work with the Water and Wastewater Services Division at Niagara Region. I work with a team of staff that is dedicated to producing clean, safe drinking water and to assuring that our wastewater is effectively treated before it's returned back to the environment. Why is it important for water in nature to be clean? Well, we use that water for a lot of different things. We might use it for boating, or to go swimming in, or for other types of water sports. We treat that water in our treatment plants and send it out to your homes so that you can drink it, cook with it, and bathe in it. What about animals? They use water too. We have lots of animals in the region that use our lakes and our rivers as their homes and habitats. Fish, birds, frogs, deer, beavers, insects, they all use that water as their home. Aquatic plants also live in the lakes and rivers in Niagara, and the water needs to be safe for them as well. So today we're going to talk about a sample of water that we've collected from the Welland Canal. The Welland Canal is a man-made waterway that connects Lake Erie to Lake Ontario. It provides a way for ships to climb the escarpment and deliver goods and products. The Welland Canal can also be fun, as we talked about before. We can use the Welland Canal for things like rowing, kayaking, boating, and swimming. We also draw water from the Welland Canal to feed 4 of the 6 water treatment plants across Niagara Region. So here I have this bucket of water, as I said, that we got from the Welland Canal. If you were here in person, do you think you'd want to take a sip of this? Well, I hope not. There's a problem. It has to be treated first. So at our treatment plants, we take out all of the things we can see, like rocks and sticks and visible dirt. And then we take out the things that we can't see, like bacteria and viruses. And then we send it out to you for you to drink at your home with a little bit of chlorine left in it just to keep it safe and make sure those bugs don't have an opportunity to grow again. Animals also live in this water, as we talked about, so we got to make sure that it's safe for them. So today we're going to complete 4 different tests just to see whether this water is safe for the creatures that live in the Welland Canal. These test materials come from a kit called World Water Monitoring. People in countries all over the world use these kits to test their water and make sure that it's safe. We all have to work together to keep our lakes and rivers healthy. So the 4 tests we're going to complete today are turbidity, dissolved oxygen, pH, and temperature. When we talk about turbidity, we're talking about measuring how clear the water is. It's important to understand that we're talking about clarity and not color. In the water world, those are 2 different things. So let's work through an example together. Let's think about a packet of Kool-Aid. I don't know if any of you have ever made Kool-Aid at home. You have a little packet of powder, you tear it open, you pour it into the water jug and stir it up, and that water changes color, right? So let's say you were making the Kool-Aid in a glass jug, clear glass. You've added your powder to the water, you've stirred it up. When you look through the side of that jug, can you see the spoon through the side of it? Yeah, you can. So that shows us how water can have color, but still be clear. We can still see through it, even though it might be red or orange or purple. When we talk about turbidity, it means that that water is cloudier and it's much harder for us to see that spoon. Low turbidity means that our water is clearer. Higher turbidity means that our water is less clear and harder to see through. We prefer to have water of low turbidity that is clearer. The animals prefer it too. For fish, it makes it a lot easier for them to breathe when the water isn't full of little particles that get trapped in their gills. For plants, it makes it easier for those plants to access the sunlight, which they need to create oxygen through photosynthesis. When the water is cloudy, they can't access that light as easily, and it's harder for them to grow. So I have a cup here from this World Water Monitoring Kit. In the bottom of this cup, there is a black and white sticker. This sticker is called a Secchi disc, and it's a tool that we can use to check the turbidity of a sample. If our water is nice and clear, we will see low turbidity, and we should be able to see that sticker really well in the bottom of the cup. If our water is cloudy, if it has higher turbidity, we won't be able to see that sticker so well. So I've filled my cup up with water from my bowl, from my sample from the river. And now, if you take a look inside that cup, you can see that black and white sticker. We can see it pretty clearly in this sample. That's a pretty good indication that our water has low turbidity. So we've passed the first test. As we see back here, low turbidity is good, higher turbidity is bad. It looks like the sticker on this end, on the good end. So we've passed our first test. The second test we're going to complete together today is a test for dissolved oxygen. What do we know about oxygen? Well, oxygen is a gas. It's in the air we breathe. We need it to survive. Did you know that we can also find oxygen in the water? Fish need it too. As we talked about just a minute ago, fish breathe through their gills, and they pull oxygen out of the water using their gills. So it's important for water to have oxygen in it as well. Let's think about that Kool-Aid example again. So you've poured the powder from your Kool-Aid pouch into your jug, and you've stirred it, and then the powder disappears. Where did it go? Well, it didn't actually disappear, it dissolved. So it got into the water, and then those little tiny crystals of Kool-Aid broke down even further, broke apart, and dissolved into that water. Oxygen does the same thing. When we add oxygen to water, when we have oxygen meeting a surface of water, that mixes up, and some of that oxygen dissolves into the water. If some of you have a fish tank at home, you might have a bubbler. The purpose of that bubbler is to introduce oxygen into the water and keep the water fresh for the fish. So we're going to complete this next experiment. I have here some tablets that are used to test for dissolved oxygen. These are called reagent tablets. When we use these tablets in a test, they react with our water and tell us something about how much oxygen is in this water. So I've added my tablets to my vial. I've filled the vial with water. And now I'm just going to shake. And I'm going to keep shaking this until these tablets dissolve. I've finished shaking up this vial. We can see that the tablets are pretty much dissolved in here. You can also see that this water has changed color. It's a little bit of a peachy browny tone to it now. So that shows how our reagent has reacted with the water to tell us something about the amount of oxygen in this sample. Let's take a walk over here. This table, this chart, shows us how to read this dissolved oxygen sample. If there was no oxygen in the water at all, this water would still be clear. And that's not great. That's very bad. So I'm going to take this vial and slide it down this chart. Does this color match what it looks like at 0 parts per million? I don't think so. Let's keep going. How about 4 parts per million? We're getting closer. Now that looks like a good match to me. 8 parts oxygen for every 1 million parts of water. That's the concentration of oxygen in this sample. And that's a good concentration for the creatures that live in the Welland Canal. Our third test today is a test of the pH of our water. What is pH? pH is a measure of how acidic or basic the water is. If you have a swimming pool at home, your parents might go out with those little dip strips and take a sample, dip it in the pool to check the pH. The pH scale, as we can see back here, ranges actually from 1 to 14. 1 is very acidic, 14 is very basic. Some common acids that we might know are lemon juice. It has a pH of 2. Vinegar has a pH of 3, and coffee has a pH of 5. Bases that you might find around the house are baking soda with a pH of 9, hand soap with a pH of 10, or bleach with a pH of 13. Right in the middle of that scale is pH 7. That's what we call neutral. It's not an acid or a base. It's just happy right in the middle of the scale. The animals that typically live in lakes and rivers prefer a pH of about 6.5 to 8. If that pH is too high or too low, beyond that range, those animals might leave to try and find somewhere else to live that's more comfortable. They might stop reproducing, stop having babies or offspring, or they could die. So it's important for us to keep track of the pH of our water in our lakes and rivers. pH can be affected by rain or discharges to lakes and rivers from treatment plants or from manufacturing plants or other businesses and industries. So we're going to test our pH now. I have this vial here, long skinny vial, and then I have another different set of reagent tablets. The ones we used before were for dissolved oxygen. These ones will help us to check our pH. So I have one of these tablets that I'm going to place into my vial. And now I'm going to dip this vial in the water to fill it up. Let's put the stopper on top. And now again, we shake. So I've shaken up my vial and dissolved my tablet into the water. We can already see that the color of this sample has changed a little bit. Let's go back to the pH scale to see where it lands. If I start up at the top, closer to some of the more acidic pHs, we can see we're not at a good match yet. We'll keep traveling down the chart. Oh, I think we should stop here. I think this is a pretty good match. So this sample has a pH of about 7, pH neutral. You'll remember from before we said that animals prefer a pH of between 6.5 and 8. So a pH of 7 is pretty much perfect. Our final test today will be to check the temperature of our sample. As most of us probably know, temperature is a measure of how hot or cold something is. So when we get hot, what are some things we can do to cool down? Well, we could sit in front of a fan, we could throw on a swimsuit and go swimming, or maybe we can just take off some layers of clothes to cool off. What about when we get too cold? Well, when we get cold, we could put on a sweater, we could sit by a fireplace, maybe we could have a cup of hot chocolate to help us warm up. Now, I don't know about you, but I have never seen a fish in a sweater drinking hot chocolate by the fire. So how do they change their temperature or regulate their temperature? Well, fish and creatures that live in lakes and rivers can't adapt to changes in temperature as well as we can. They need to have a nice steady temperature that doesn't change up and down too much. If temperature does change a lot, they can get really stressed and they can die. For plants, temperature is really important for photosynthesis. Photosynthesis is the process that plants use to take energy from the sun and create oxygen. In colder water, plants want to have more sun, so they increase their rate of photosynthesis and they create more oxygen. So colder temperatures are better for plants as well. So we're going to check the temperature of our sample today. Here I have another one of these cups. Along the side of the cup is a sticker. Again, if you have a fish tank at home, you might have seen a sticker like this before. This sticker will change color to show us the temperature of our sample. So I'm going to dip our cup into the water. And as you might be able to see here, the temperature looks to be between 18 and 20 degrees. Now this water has been inside for a little while, so it's warmed up a little bit. It might not be quite as cold as it was when we first collected it from the canal. Let's take a walk over to our temperature chart. For our fish, as we said, cool water is good water. Fish are happiest in the range of 14 to 18 degrees Celsius. If we're sitting at about 18 degrees Celsius with this sample, then our temperature is pretty comfortable for our fish and aquatic life as well. So let's recap what we've learned today. What did we learn about the water in the Welland Canal? In our first test, we looked at the turbidity of the water from the canal. You'll remember that turbidity is a measure of how clear the water is, whether there are things floating in it or not. We looked into this cup and we saw that black and white Secchi disc very clearly, which means that our water is nice and clear for our animals and fish and plants. The next test we talked about was dissolved oxygen. You'll remember that dissolved oxygen is the oxygen that has dissolved into the water. We tested this with a dissolved oxygen reagent, and our water turned this peachy brown color, which shows us that there is a good amount of dissolved oxygen in the sample. This is also good for fish and animals and other creatures that live in the river. Our third test was pH. You'll remember that pH is a measure of how acidic or basic the sample is. We talked about common household acids like vinegar and coffee. We talked about common household bases like bleach and hand soap. And then we checked the pH of this sample, which was pH 7 or pH neutral. Again, a very healthy environment for our fish, animals, and plants. The last test we completed was temperature. We filled this cup with water from our Welland Canal sample, and we checked the temperature scale. You'll recall that the fish and creatures in the canal and lakes and rivers prefer cooler water between 14 and 18 degrees Celsius. This sample measured 20 degrees Celsius between 18 and 20 degrees Celsius. So it's a pretty good environment for our fish and animal friends. So our water sample has passed all 4 tests, and we've confirmed that it's a good environment for the aquatic life living in the Welland Canal. It's important that all of the plants and animals in the canal stay healthy. All of those animals and plants are part of the food chain. When one of those suffers, other animals and plants suffer as well. It's important to keep our ecosystem healthy by protecting our natural waters. Thanks for watching. I hope you enjoy the rest of the festival.